So this lesson then is on negative and zero exponents. So when you ever have something raised to the power of zero, the answer is always going to be 1. Doesn't matter whether it's a number raised to the power of 0 or a letter raised to the power of 0, the answer is always going to be 1. Whenever you have a negative exponent, and that negative exponent is located in your numerator, what you need to do is basically what I like to call flip out, because you're going to flip whatever base is attached to the negative exponent from either the top of the fraction to the bottom or the other way, bottom to top. And once you flip that base with its negative exponent, you need to take out the negative sign. So what's happening here is a to the negative n right now is in the numerator. We've got to flip a to the denominator, and once it moves to the denominator, you out the negative or it becomes positive. If something's in the denominator and there is no numerator, it has to be a 1. So for this particular example on 2, right now y to the negative 3 is over a 1. I need to find that I have a negative exponent attached to the y. What I'm going to do is I'm going to flip the y from the top to the bottom, and I'm going to out or remove the negative sign. And now that I've got y cubed in the bottom, I need a top number. It's always going to be a 1. When the negative exponent is in the denominator, a to the negative n, you're doing the same thing. You're still going to flip out. So I'm going to move the a from the bottom to the top, and I'm going to out the negative exponent. So this is why when it's 1 over a to the n, it becomes a to the positive n over 1. So that happens on this example right here. I've got z to the negative 4th power in the denominator. What I'm going to do is flip the z to the numerator. My negative 4 becomes a positive 4. I could put this over a 1 because that's where the 1 actually would go. If there's nothing on the bottom, it's a 1. Or I would just leave it as z to the 4th. Let's try a couple of examples. We need to make sure that there's no zero exponents in our answers or there's no negative exponents. There's lots of different ways to do these problems. I probably won't show you more than one, so you need to decide which way is better for you. Maybe I will show you a few different ways. The first one, what I would suggest that you do is put the whole thing over a 1. And then I'd say, okay, I have a negative exponent right here. It's 3 to the negative 4th. The 3 to the 7th is not negative. It doesn't go anywhere. So I would take my 3 to the 7th and carry it over. I would flip my 3 to the negative 4 from the top to the bottom, and once I flip it, I out the negative. And then I go back to the rules from the beginning of this unit, and I say, well, where are there more 3's, top or bottom? And they're on top. How many more are there? There's 3. So this answer becomes 3 cubed. Not a problem by actually simplifying this even further and saying that, well, 3 cubed is just 27. The other way to possibly do this, and again, you have to decide what you like better. If you remember from the rules from the first day, we said if ever the bases are the same, you could just add the exponents. And if I do that, if I just add my exponents, well, 7 plus negative 4 is just 3. And that's still going to get me the same answer. You need to choose what's best for you. On the second example, I've got 2 to the 4th, 2 to the negative 4th, and 2 to the 0. Well, anything to the 0 power is just 1 whole. And if I do this the way I did the first one, I would then put this over a 1, and I'd realize that I have a negative exponent here. I'm going to flip that thing down to the bottom. I'm going to out the negative. This top 2 to the 4th comes over as is. The one that's circled in red, that 2 drops to the bottom. You out the negative. It becomes a positive. And then it's where are there more 2's, top or bottom? Well, they're equal. And anything divided by itself is just 1 whole. That's your final answer. Again, the other way to do this, put a little line over here. We know that this guy is going to be gone because it's 2 to the 0 or 1, but if we take the rules from the beginning of the unit, if we just add our exponents together because the bases are the same, you get 2 to the 0, but you know anything to the 0 power is just 1. Next example. Again, put everything over a fraction bar. What's happening here is A has a negative exponent and B has a negative exponent. Both A and B have to flip out. When A drops to the bottom, its negative exponent goes positive. When B drops to the bottom, its negative exponent goes positive. And now I have nothing over A squared B to the fourth, but you always need a numerator. That numerator becomes a 1. There's your final answer. Next example, I've got x to the negative 3 squared, x to the negative 6 to the negative first power. If you go back to the rules from the beginning, anytime you have a power to a power, you can just multiply those exponents. This would become x to the negative 6. This would become x to the positive 6. You can flip out, or you can realize that x to the negative 6 and x to the positive 6 is just x to the 0. And there's your answer of 1. Next example. You've got 5x squared y to the negative first, all to the power of 0. This one's nice because the whole thing is just a 1. When you get to this next one, it gets a little bit more confusing. So it looks, but it really isn't that big of a deal. Circle any bases that have negative exponents and circle the exponent with its base. So x to the negative 2 gets circled, z to the negative 3 gets circled, x to the negative 5, and y to the negative 2. Those are the only things that flip out. What doesn't go anywhere? On the top, 12y to the 7th never got touched. 4z to the 2nd never gets touched. From the top, x negative 2, it moves down and becomes x positive 2. The z negative 3 on the top moves down for a z positive 3. The x negative 5 on the bottom goes up for x positive 5. The y negative 2 from the bottom goes up for y positive 2. Now you have to decide if you want to combine some like terms now or wait. I'm going to combine things that I can first, which means in my numerator I've got 12. There's y's. I've got 7 and I've got 2 or 9 y's. X to the 5th. On the bottom I have a 4. Z's, I happen to have 2 and 3 or z to the 5th x squared. Still not simplified because then you can't forget how do you divide 12 over 4. Well, 12 divided by 4 simplifies to 3 or 3 over 1 if you want. The 1 isn't necessary. And then ask your questions. Well, where are there more y's, top or bottom? They're only on the top. All 9 stay. Where are there more x's, top or bottom? They're more on top by 3. And then z's, haven't used those yet. They're only on the bottom, and they're all 5 of them. This is your final answer. Got one more to go. Wrong way. There we go. This particular problem, because the outside exponent is positive, what I would like to do is write this thing out twice. You could do power to a power if you wanted to. That's fine. But my preference would be is I'm going to write the whole parenthesis out twice, which means I have 2x negative 4y, 3x negative 3y negative 2z, and then again 2x negative 4y, 3x negative 3, y negative 2z. I'm going to combine this all to one fraction. I know that I'm multiplying, and I know that when I do multiplication, that 2 times 2 is just going to give me 4. Whoopsie. Put that down. 2 times 2 is 4. X to the negative 4th. X to the negative 4th is just going to give me x to the negative 8th. And then y up top and another y up top is y squared. On the bottom, 3 times 3 is 9. X negative 3, x negative 3, x negative 6, y negative 2, y negative 2, y negative 4, and z1 is z2. Now we got to do some flipping out. Let's see. X has a negative exponent to the negative 8. X down here has a negative exponent, negative 6. And y has a negative exponent. What does not move stays in black and stays where it is. So I've got 4y squared over 9z squared. I'm going to move x to the negative 8 to the bottom, out the negative. I'm going to move x to the negative 6 up top, out the negative. I'm going to move y to the negative 4 up to the top and out the negative. And then what happens here is I've got 4 y to the 6th, x to the 6th over 9 z to the 2nd, x to the 8th. Whoopsie, that's an 8. And then my final answer, let me get some more room here. The final answer ends up becoming 4, more y's on top. All the y's actually are on top. X's, more x's on the bottom by 2. And then the 9 and the z squared. Final answer. Feel free to put the variables in alphabetical order. It doesn't really make a difference. And that's it. So this should be okay for the homework sheet.